All right, let's get right into it. You've heard all the hype about AI, right? We're constantly hearing about how powerful it's getting. But what if the real next step isn't just about more power, but more, well, more sense? That's exactly what we're talking about today with Neuro Symbolic AI. It's this wild idea of building a hybrid mind, one that might get us closer to what we think of as actual, genuine understanding.
So you've probably seen this yourself. AI can write a beautiful poem, it can generate incredible art, and then it can turn around and say something that's just completely confidently wrong, like this. An LLM might spit out something like, Einstein discovered gravity in 1687, and it says it with such authority. This is what we call an AI hallucination, and it points to this massive problem at the heart of even our best models. They can mimic intelligence, but they don't really know anything.
And yeah, that's the big question, isn't it? How can something be so brilliant one second and so unbelievably off the next? How can it write complex code but get a simple fact about science completely backwards? Well, the answer, as you might guess, is buried deep inside the machine itself.
And this gets us to what experts call the black box problem. It's this idea that with a lot of modern AI, we can feed it information, and we can see what it spits out on the other end, but what happens in the middle? That's, well, it's a mystery. A lot of the time, even the people who built it don't fully understand its reasoning.
The best way to think about these neural networks is that they are amazing pattern matchers. Seriously, they're brilliant at it. You show them a billion pictures of cats, and they'll get incredibly good at spotting a cat. But here's the catch. They don't know what a cat is. They're just matching patterns. They don't operate on logic or rules or common sense. And that's why they're so hard to trust, especially when the stakes are high and you really need to know why it made a certain decision.
So, to really get how we can fix this, we need a little backstory. For a long time, the world of AI has basically been split into two camps, two competing philosophies. You can kind of think of them as two rival tribes, the logician and the artist. First up, we've got symbolic AI. This is our logician. This type of AI is all about logic and rules. I mean, literally. It's built on a foundation of if this, then that. Think of a super detailed flowchart for everything. The huge plus here is that you can always see exactly how it reached a conclusion. It's totally transparent. But the big weakness? It's super brittle. The moment it runs into something that's not in its rulebook, it just breaks. It can't handle ambiguity.
And then you've got the other tribe, neural AI. This is artist. This is the AI we hear about all the time now. It's the engine behind deep learning. The artist doesn't care about rules. It just wants data, mountains of it. It looks at all that data and just learns. It develops an intuition for patterns. It's incredibly powerful and flexible, but like we said, it's a total black box. We have no idea how it does what it does.
So here you can see it laid out side by side. You've got the logician, rule-based, great at reasoning, but fragile. And then the artist, data-driven, amazing at learning, but completely unexplainable. And for like decades, AI research was all about picking a side. You were either team logician or team artist.
It really boils down to this. One masters rules, the other masters patterns. These two approaches seem like total opposites. But what if you didn't have to choose? What if you could bring them together?
And that is where things get really interesting. Because a new idea started to take hold. Instead of making these two tribes fight it out, what if we could get them to work together? What if we could build a hybrid mind that gets the best of both?
And that's the big idea behind Neuro Symbolic AI, or NSAI for short. It's a type of hybrid architecture that literally combines the pattern-spotting genius of the neural networks, our artist, with the cold, hard logic of symbolic AI, our logician. The whole point is to finally bridge that gap between just seeing something and actually understanding it.
Here's probably the simplest way to picture it. Think about that brilliant, intuitive artist we talked about. Now imagine you give him a notebook and a pen. They can still create these incredible works just from intuition, but now they can also jot down some rules, check some facts, and apply a little logic to what they're doing. They can essentially show their work.
So how does this actually work? Well, in a nutshell, it goes something like this. First, the neural network part, the artist, does what it does best. It looks at all the messy, real-world stuff, like an image or a block of text, and finds the patterns. Then, the symbolic engine, the logician, steps in. It takes those patterns and applies a set of rules and logic to them. It provides a structure, the common sense. And by working together, they can achieve a level of reasoning that's way more complex and, frankly, more human-like.
And look, this isn't just some sci-fi idea. People are actually building these things. A great example is something called the differentiable neural computer, or DNC. The best way to think of it is that the neural network is the CPU, the processor, and it's connected to an external memory, which is like the RAM in your computer. It can learn to read from and write to that memory, which lets it handle complex information in a structured way. But it still has all the learning power of a neural network. It's pretty wild.
Okay, so we've covered the how, but now for the big one. So what? Why does any of this matter? Well, it's about trust. It's about moving away from these mysterious black boxes that we just have to hope are right, and towards something more like a clear box, where we can actually look inside and understand the decisions being made.
Let's make this real. Think about medicine. A normal AI today might be able to look at a scan and say, there's a 95% chance this is cancerous. And it might be right. But if the doctor asks why, the AI has no answer. It just saw a pattern. A Neuro Symbolic system, on the other hand, could give the same diagnosis and then provide a traceable, logical reason for it based on established medical knowledge. A doctor can actually follow its reasoning. I mean, that's not just an improvement, that's a total game changer.
And the possibilities just explode from there. Think about self-driving cars. You need an AI that can see the world around it. That's the neural part, but also one that knows and obeys the rules of the road. That's the symbolic part. Or in engineering, you could design new materials based not just on what patterns suggest might work, but on what the laws of physics demand. You could even apply it to entire smart cities, making decisions about things like traffic flow using both real-time data and established logistical rules.
So when you put it all together, what do you get? You get an AI that's way more reliable because it's not just guessing based on patterns. A lot of the time, it needs less data to get started because it has a foundation of rules to build on. And this is the big one, you get an AI whose decisions you can actually explain, you can audit, and you can finally trust.
This all leads us to think about the future, and not just in a technical way. Because this whole neurosymbolic approach, it's more than just building a better tool. It really starts to push us to ask some pretty deep questions about what intelligence even is.
And this quote here from Leslie Valiant, who's a Turing Award winner, basically the Nobel Prize of Computing, he just nails it. The goal is to figure out how something can learn from experience, but then also reason about what it's learned. That's not just a coding challenge. That's the whole ballgame. That's the quest for the holy grail of AI.
So that really leaves us with this massive question. As we start to successfully merge this intuitive pattern matching ability with structured logical reasoning, are we just making a fancier calculator, or are we actually taking the first steps toward building a completely new kind of mind?
And just when you think you've got your head wrapped around it, here's one final thought for you. Maybe the ultimate hybrid isn't going to be trapped inside a computer at all. Get this. In actual experiments, scientists have built little robots that can give off the right chemical signals to basically trick a group of cockroaches into accepting them. And then, the robots start to influence the group's decisions. The line is already blurring. The future of intelligence might not be just about smarter algorithms. It might be a collaboration between the artificial and the biological. Now that is something to think about.